welcome to class today. Today we are going to continue from where we stopped the last time under trigonometry. So we want to look at real life problem this time around, and I can assure you it's going to be an interesting aspect. Okay, so before we commence the class, I want you to invite your friends, let them know the class has started. Okay, and don't forget, if you are just joining this platform, ensure you give this class a thumb of like, and also don't forget to subscribe to this channel. All right, so now let's wait for others to join the class. So you can share this link with your friends, your classmates, let them know the class have started. Okay, let's see the number of those that are available now. All right, let's continue. So don't forget, joining, you quickly invite your friends that you feel probably maybe they are not online. All right, the last time, let's quickly do a review of what we did the last time. Now, the last time we looked at some problem under triangles, and we looked at special angles. And I told you that there are certain angles that you need to know their function. You should know the sine, cos, and tangent of their functions. And we looked at example. We have angle 30, angle 45, and angle 60. So you must be able to tell me, without making use of your calculator or your four-figure table, able to tell me what sine 30 is, cos 30 is, and tan 30. The same thing also applies to 45, angle 45, and that of 60. All right, so the last time we looked at problems that are involving special angles. All right, so now we are still going to continue on that note, but this time around we want to look at real life problems. So we are starting with angles of elevation and depression. Angle of elevation and depression. Okay, so I think we have we can see there's an improvement. Okay, so as you're joining the class, don't forget to give a like to the class. All right, so now I'm going to explain the concept of elevation and depression. Now, the word elevation means you raise up. When you have to elevate your head, you raise your head up. Now, depression means you bow down. Okay, you look at something beneath. All right, so now let us look at it. Suppose we have a viewer here and we have an object here. Now, every normal human being will look straight. So this one is the normal view. But now, if this guy need to elevate his head, so that means he has to raise his head up. All right. If you need to look at something at the top here, he needs to raise his head up by a particular angle. All right. So we'll have this. So he must have raised his head with a particular angle here. Now this angle is what we call the angle of elevation. All right. So now this is angle of elevation. This is the angle that the guy here, covered by raising up his head. All right. So now let us now look at angle of depression. All right. Suppose this man is on a tower like this, and you need to build something on the ground level. Right. You need to depress his head. Right. So he's going to look down at this thing. right? So the angle here is what we call angle of depression, because he has bent down his head by a particular angle. That angle is what we call angle of depression. And that's just the idea of what we want to do now. Okay, so I want to believe everybody understand what I'm talking about. When we talk about angle of elevation, now it is the angle covered by a head that is moving up. Okay, an observer, the head of the observer, the angle covered by the head of the observer looking up, that is what we call angle of elevation. All right. Now, the angle covered by the head of the observer looking down is what we call angle of depression. And that's all. Now, let us look at an example and let's see how we put that into practice. Now, let's look at this question. Now, yeah, the angle of depression of a point R from the top of a tower P is 30 degrees. Now, if the distance of R from P is 50 meters, how far is R from the foot of the tower? All right, now, so the first thing we do now is we draw the horizontal ground. Okay, and we have the tower here. Let's say we have the tower. This is the tower. Now, let's come back to the question. Now, and of course, now, you know, anytime you have a tower is always perpendicular to the horizontal ground. And don't forget that. Now, the angle depression of a point R from the top of a tower P. The angle of depression of point R from the top of a tower P. Top of a tower is P. Can you see that now? From the top of a tower. So that means we have an observer, you know, somewhere here, because if you need to depress your head, you must be at the top. Okay? So since we have the observer here, the observer will first look straight. This is the initial view. So because he needs to depress his head, so we have to look down. So now the angle of depression, this is the angle of depression. So, and the angle of depression has been given to be what? 30 degrees. Now, he's looking at a point beneath. And what is that? The angle of depression of point R. So this place is point R here. Okay, the angle of depression of a point R from the top of a tower P is what? 30 degrees. So that's the interpretation of the question. All right. So now the question I'll go further and say, if the distance of R from P is 50 meters, the distance of R from P is 50 meters. So this is 50 meters. Okay. Now, how far is R from the foot of the tower? This is the tower, and this is the foot of the tower. Let's represent it with F. Now, this is the foot of the tower. All right. So, how far? So, we want to know the distance FR. Okay. So, now, how do we go about this? Now, the first thing you need to know is that this line, broken lines now, is parallel to this line here, the horizontal ground. So, that means this angle here will be alternate to this angle here. So this place is going to be 30 degrees as well. All right. So now we now look at this triangle PFR. Look at this triangle PFR. It's a right angle triangle. I want to get this part. Now when you look at this triangle, you will see this is the adjacent, this is the hypotenuse, and this is the opposite. And don't forget I told you, adjacent is the side that touches the right angle and the reference angle. All right, now, so we are combining adjacent and hypotenuse. So making use of our SOHCAHTOA. So which trig function are we going to use? Look at it, we have adjacent and what? hypotenuse. Adjacent and hypotenuse. So it's going to be car. Cos is for what? For cos. So we write cos of 30 degrees equals to adjacent, which is x, over hypotenuse 50. So here you can cross multiply. So you have x equals to 50 cos 30 degrees. All right. So x is 50. Now you need to tell me what cos 30 degree is. Okay. So I want you to drop your answer in the comment section. Now let's quickly do that. I told you you must master all these special angles. Okay. Now let me see. I want to see the first person that will give me the correct answer. So if you're in the last class, you should know what cos 30 is. Okay. Is there anyone dropping his or answer? Cos 30, what is cos 30? Yes. Cos 30. Cos 30, what is cos 30? So I'm expecting answer to be rolling in. I told you the last time, you need to master all this. Okay, you need to master them, and probably have to write it in your jotter. Make sure you know all of these without making use of your calculator. All right. Now, your cos 30 is square root of 3 over 2. Okay, so now this is multiplying this now. So 2 goes here, 1, 2 goes here is 25. So that means the answer is x equals to 25 square root of 3 meters. Okay, x is 25 square root of 3 meters. Okay, so that is the answer. All right, so that's the distance between point R and the foot of the tower. All right, and don't always forget, whenever you're answering questions like this, always remember to put the unit. Very, very important. Okay, so now let me quickly. So if you have forgotten, the special angle is very, very important. Now, your sine 30 is the same thing as cos 60 degrees, which is the same thing as 1 over 2. You can see the relationship. Sine 30 equals to cos 60 equals to 1 over 2. So there may not be a need for you cramming all this. So also look at this. Sine 60 degrees is the same thing as cos 30 degrees. And the value is square root of 3 over 2. So you can always master that. All right. We have another one. We have sine 45 degrees is the same thing as cos 45 degrees, which is square root of 2 over 2. Or we say 1 over square root of 2. So it's also the same thing as square root of 2 over 2 when you rationalize the denominator. Okay, so now that's that. Now tan 45, that one is very simple. Tan 45 is 1. So all of this, you can write this in your jotter so that anytime you just meet this type of special angles, so you know what to write. You don't need to be punching your calculator. Okay, and the remaining one, we have tan 30. Tan 30 degrees is 1 over square root of 3, and the tan 60 degree is square root of 3. Okay, so this all you need to know. All right, so these are the special angles. All right, okay, so and that's all. All right, so now let's move down to another question. So you can put this one down in your notes. Now let's look at another question. Example 2. The angle elevation of x from y is 30 degrees. If length xy equals to 40 meters, how high is x above level y? Okay, this is another wonderful question. Now this question is under angle of elevation. Okay, now let's look at the questions together. Now the angle of elevation of x from y is 30 degrees. So now if length xy is 40 meters, now how high is x from the level of y? All right, now, so the first thing you need to know now is that the observer should be beneath, it should be on the ground, because once we're talking about angle of elevation, that means the observer is probably below, looking at something above, because he needs to raise up his head up. So now let's see. Now this is the observer here, and we have, let's say we have a pole here. Let's say we have a pole here, which is at the same level with the observer. So the observer is here. Okay, so and the pole is always at right angle to the horizontal. Now, let's read the question. The angle of elevation of x from y is 30 degrees. The angle of elevation of x. Now, this is x. The angle of elevation is here, all right? Because the question says from y. From y, that means y has the angle of elevation. So this place is going to be your y. So now the angle of elevation, the observer must have raised his head by what? 30 degrees. Okay, now look at this diagram now. The angle of elevation of this x from this y is 30 degrees. Hope you understand that. Okay, so now if length xy is 40, from here to this is 40 meters. Now the question is, how high is x above the level of y? All right, we want to get the height of x. All right, so now let's call this place f. All right, so we want to get length xf. So how do we do that? Now the first thing to look at now, this place is your opposite, this is your adjacent, and this is the hypotenuse. Okay, since I want to get the opposite, so I'm connecting O and H. So when you look at your SOHCAHTOA, I think this one is going to be the one you're going to use. We have O and H. So here now we have sine 30 degrees equals to opposite. That is what we're looking for. That's xf, okay, over hypotenuse, that is 40. So we cross multiply. So we have xf equals to 40 sine 30. Okay, so this time around now, you should be able to tell me what is sine 30. What's going to be the value of sine 30? So I expect everybody now to give me the answer. I just said it not quite long. What is sine 30? Yes. Okay, I can see Banjo giving me answer. Sine 30. Yes, I can see Muiz. Okay. Joseph. Scott. Yes. Pamela is not giving answer. Okay. It's just welcoming us. Okay, so all right. So that's good. Because sine 30 is 1/2. All right. So now multiply half and 40 together. So you have 2 goes there 1, 2 goes there 20. So we have xf equals to 20 meters. All right. So therefore, the height of x above the level of y is what? 20 meters. So that is the answer to that problem. You can see it's just straightforward. All right, now can we look at another question? Okay, so if you are just joining this class for the first time, yes, don't forget you need to subscribe to this channel. If you love what we are doing here, so you subscribe to this channel so that you'll be notified on here. And also, if you are also if you have subscribed and you have not give a like, make sure you do. All right, now let's move down to another question. Example 3. Let's look at example 3. Example 3. The angle elevation of the top of a cliff. Angle elevation of a cliff. A cliff 15-meter high. From a landmark is 60 degrees. How far is the landmark from the foot of Okay, this is another wonderful question. All right, now let's look at the question together. Okay, so now the angle of elevation of the top of a cliff is 15 meters. So 15 meters high from a landmark is what? 60 degrees. So how far is the landmark from the foot of the cliff? All right, so now this question is telling us we have a cliff. Right, so you draw your horizontal ground. That's the first thing we draw. We have a cliff. And let's assume we have a cliff of this form. Okay, and a cliff is always right angle to the horizontal ground. So we have your right angle. Now let's look at it. The angle of elevation of the top of a cliff 15 meter high, 15-meter high. That means this cliff is what? 15-meter high. 15-meter high from a landmark 60 degrees. 60 degrees. So we have a landmark here, which is what? Which is which has an angle of elevation of 60 degrees. So the question is, how far is the landmark, that is the landmark here, from the foot of the cliff? This is the foot of the cliff. All right. So now let's name the top of the cliff A. Now the landmark, let's name it B. And the foot of the cliff, let's name it C. Okay. So the question wants us to get how far is the landmark from the foot of the cliff. We want to get length BC. Hope you understand that. This is the landmark and this is the foot of the cliff. So you want to get the distance. Now the observer is here, don't forget. All right. So the observer have elevated his head by 60 degrees, being the top of a cliff which is 15-meter high. So that's just all about the question. Okay, now let's solve this problem now. All right, so now what are the two sides that we're looking at? This side, because we want to get BC, this side and this side. So we are looking at the adjacent and the opposites. So I think that's going to be your tour. Let's look at it. So tour. Can you see that? The opposite and the adjacent. So we are connecting this and this together. All right, so we have tan 60 degrees equals to opposites, that is 15, over adjacent, that's BC. Okay, so here we can cross multiply. All right, so when you cross multiply, you have BC tan 60 degrees equals to 15. Okay, so we have BC equals to 15 over tan 60 degrees. So BC will be, now, can you tell me what is tan 60? All right, without the calculator, what is tan 60? Yes, what is tan 60? Good. I can see someone giving me the answer. That's familiar. I love that. Okay, so now can we? All right, I can see Omolara, square root of 3. Yes. Anyone else? Anyone? Tan 60. Tan 60. I've mentioned that today. Okay, what's tan 60? Okay, I can see Riscott answer. Okay, so I want every one of you to drop his or her answer, right? Okay, so now tan 60. Tan 60 is square root of 3. Square root of 3. That is tan 60. I think I've said that today. Tan 60 is square root of. So that means our answer BC will be 15 over square root of 3. Okay. All right. So now, and it's going to be in meters. Don't forget. Always remember to put it in meters. So I can also express this my answer in another form. Now, what I want to do, I want to rationalize the denominator. I can leave my answer this way, but I can express this answer in another form. So what I'm going to do now is I will multiply the numerator by square root of 3. I will multiply the denominator by square root of 3. Okay, so this is also the same thing as 15 times square root of 3 over square root of 3 times of 3. Okay, I want every one of you to look at this. Now we have 15 over square root of 3. So now I said it's the same thing as 15 times square root of 3 square root of 3 times square root of 3, because this cancel this. We still have 15 over square root of 3. All right, now, so now let us multiply now. If I multiply this, square root of 15 times square root of 3, that's going to give me 15 square root of 3 over. Now, square root of 3 times square root of 3, that gives me square root of 9. And what is square root of 9? That's 3. So square root of 9 is 3. Okay, so I can simplify this one further. I see 3 goes here 1, 3 goes here 5. So my answer is going to be 5 square root of 3 in meters. So this and this have the same numerical value. All right, so this and this have the same numerical value. So it's either you express your answer in this form or this form. So that's the answer to the problem. All right, I think we are now ripe for something to try. Let me see if we can quickly do this before we move on. Let me give you something to try. Okay. Okay, try this. From the top of a cliff 90 meters. From the top of a cliff 90 meters high, the angle of depression of a boat is 30 degrees. Calculate how far the boat is A, on the foot of the cliff, B, from the top of the cliff. Okay, yes. So that is the question. That's your question. I want every one of you to try. Let me have your answer in the comment section. So I trust you guys that you're going to do it within a very short time. Okay, now let's quickly do this and let's see. We want to see the first person to give us the correct answer. Right? So let's quickly do that. From the top of a cliff, 90-meter high, the angle of depression of a boat is 30 degrees. Calculate how far the boat is from the foot of the cliff and B, from the top of the cliff. Now let's do that within 2 minutes before we give the solution to the problem. All right, we have like a minute more to provide our answers. We have like a minute more to provide our answers. Okay, that's good. I can see an answer. Pamela, I've provided answer for A. We have 90 square root of 3. Okay, so I'm expecting you to put units. Don't forget, unit is very, very important. So let's know the units. Okay, by now we should be dropping our answers. We have to make it faster. I can see that. So the second part of the question. Okay, Riscott, you have an answer. Okay, you are waiting for others to provide their answers. We have exhausted the 2 minutes. So I'm giving you like 30 seconds more to provide your answers. I'm waiting for Omolara's results. Lukman, I'm waiting for your results. And also, I have emergency. Okay, so Banjo Muiz. Okay, so and others, please ensure you drop your answer in time. Okay, all right. Okay, Lukman have dropped an answer. Okay, we have that 90 square root of 3. Okay, so what of the B part? Are we finding it difficult? So I can only see the A part. All right, because of our time, let's quickly solve the problem together. And let's solve the problem together and let's see what it's like. Now, from the top of a cliff, 90-meter high, the angle of depression of a boat is 30 degrees. Calculate how far the boat is from the foot of the cliff, from the top of the cliff. Now, the first thing to know is that anytime we are talking about angle of depression, the observer should be at the top viewing something beneath. Okay, so now let's assume this is the horizontal level. We have an horizontal level, we have a cliff here. Okay, this is a cliff. Now, the cliff is perpendicular to the ground. All right, and this is the top of the cliff where we have an observer. Okay, an observer initially will look straight, but if you need to look something on the ground, he's going to tilt his head looking at something on the ground. So Now it's going to cover a particular angle. I'm looking at something on the ground here. Okay, so it's looking at the boat. Let's say the boat is here at point B. Now the angle of depression, because he must have depressed his head by what? 30 degrees. So this place is going to be 30 degrees. This is where we have the observer. Okay, observer is at the top, depressed. Whenever you hear the word depressed, you know the observer is at the top viewing something on the ground. So this is the observer here. Now the observer depressed his head to view the boat. All right. Now, but we have been given in the question that the cliff is what? 90-meter high. So this is the cliff. We have 90 meter. And don't forget, this initial line, view of sight, is parallel to this line here. All right. So once it's parallel, that means this angle here will be alternate to this angle. So this is 30 degrees. Okay. So this 30 degrees. Now, the question now says, calculate how far the boat is from the foot of the cliff. Now, this is the boat, and this is the foot of the cliff. Let's call it F. Let's call this place T, the top of the cliff. All right, how far is the boat from the foot of the cliff? So we want to get BF. All right, so now this is what I want to get. Now look at this. This is the adjacent of this triangle TBF. This is the adjacent and this is the opposite. So we are making use of TOA. TOA is opposite over adjacent. So we write tan 30 degrees equals to opposite, which is 90 over adjacent. Adjacent here is BF. We don't know that. Okay. So now don't forget, what is tan 30? Now, can you tell me tan 30? So if you have done it, you should be able to tell me what tan 30 is. I've said it today. What is tan 30? Tan 30. Tan 30. Okay, tan 30 is 1 over square root of 3. I think that's the correct answer. So because of our time, I hope everybody is now seeing the board clearly. All right, I can see some people saying it's not clear. The board is not clear. Okay, how far now? Can you see the board clearly now? Okay. All right, let's see. Maybe there will be some level of improvement. So, okay. Okay, I can see Omolara's result. That is 1 over square root of 3. 1 over square root of 3. So now 30 is 1 over square root of 3. That's correct. So we have this as 1 over square root of 3 equals to 90 over BF. Okay, here you can cross multiply. So when you cross multiply, BF times 1. So you have BF equals to 90 square root of 3 in meters. So this is going to be the answer to the problem. All right, so that is the distance of the boat from the foot of the cliff. Now the question I'll go further. Calculate how far is the boat from the top of the cliff. The boat from the top of the cliff. This is the top of the cliff. Okay, and this is the boat. So we want to get this. All right. So how do we do this? Now, we want to connect opposites and hypotenuse. So that is going to be what? That is going to be opposites and hypotenuse. All right, now let's see that. So we have sine 30 equals to opposite over hypotenuse. So opposite is 90 and the hypotenuse is what you are looking for. So hypotenuse is BT. Okay. All right. So now what is sine 30? What is sine 30? I expect everybody to know the answer to that. What is sine 30? What is sine 30? What is sine 30? Yes. One. Okay, what is sine 30? Sine 30. All right, because of our time, sine 30 is 1 over 2. 1 over 2, which is equals to 90 over BT. Okay, length PT. So here you can cross multiply. Here. So you have this times this one times this. So we have BT equals to 2 times 90. That's 180 meters. So that's going to be the distance of the boat from the observer at the top here. Okay, so that is the answer to that problem. All right. So what is the view like? Can we see the board clearly now? Can we see the board clearly now? Yes, I need a response from you before we move to the next example. Can we all see the board clearly? All right, okay, thank you. So we have to manage the network. The network is not friendly today. So not always have our ways all the time. So, but I hope we enjoy the network for the rest of the class today. Okay, so now I'm moving down to another interesting example. Now let's look at this. Example 4. If sine theta equals to 5 over 13, find the value of okay, so that is the question. So we are going to solve this problem together now. So how do we solve this type of problem? Now, if sine theta equals to 5 over 13. Find the value of 1 plus tan theta all over 1 minus tan theta. Okay, so how do we solve this type of problem? Now, the first thing you're going to do here is you're going to draw your right angle triangle. We are going to be making use of Pythagoras theorem. So now let's look at the way we're going to do this. Now, the first thing is to bring out this. This is given. We have sine theta equals to 5 over 13. Don't forget, your SOHCAHTOA, we have, let me write this one out. We have SOHCAHTOA. Okay, so now sine is equals to opposite over hypotenuse. That's the meaning of so. So now we are giving sine theta equals to 5 over 13. So it means that opposite is 5 and the hypotenuse is 13 in the triangle from which this is gotten. All right, so now let us now draw that right angle triangle. So we have it this way. So right angle. Now the opposite, if this is the reference angle, now the opposite is 5. The hypotenuse is 13. Now we want to get the adjacent. Now let's get the adjacent. Let's say the adjacent is x. We are going to be making use of our Pythagoras theorem now. So we have opposite square plus adjacent square equals to the hypotenuse square. I want to believe you remember that. Okay, now let's do that. So we have 5 square plus x square equals to 13 square. So this is your Pythagoras theorem. So now you square this and square this. So now you have 25 plus x squared equals to 169. All right. So now you subtract 25 from both sides. So if you do that, you have x squared equals to 169 minus 25. Okay. So, and that gives you x squared equals to 144. All right. So you can take square root of both sides. So when you do that, you have x equals to square root of 144. So x will be equals to 12 units. Okay, so that's what we have. So that means in this right angle triangle, this is 12. X is 12. So we now have all the sides of the right angle triangle. Now that will help us now to be able to get tan theta. Now what is tan theta now? You can see tan theta will be equals to opposite over adjacent. So I can write tan theta as opposites. The opposite is 5. Adjacent. What's adjacent? 12 over 12. Okay, so we now know tan theta. So we can get an expression for this, or the equivalence of this. So now this 1 plus tan theta over 1 minus tan theta will now be equal to 1 plus 5 over 12 all over 1 minus 5 over 12. Okay, so now we tidy up the numerator and the denominator. So let's do that. Right, so let's do the numerator first. We have 1 plus 5 over 12. Now let's find the LCM of this. This 12. So you know this is 1 over 1. 1 goes in 12 is 12. 12 times 1 is 12. Plus 12 goes in 12. That's 1. 1 times 5. That is 5. So this gives us what? 17 over 12. This one is for the numerator. Now let's do for the denominator. So that's going to be 1 minus 5 over 12 The LCM is 12. So 1 goes in 12. 12 times 1, that's 12. Minus 12 goes in 12 is 1 times 5 minus 5. Okay, so now this is going to give you what? That's going to give you 7 over 12. Okay, so from here, you can now plug in the value here. So let's plug in. So that means 1 plus tan theta over 1 minus tan theta equals to 17 over 12 divided by 7 over 12. Okay, I hope you get that now. So this is the numerator and this is the denominator. So and that gives you 17 over 12 times 12 over 7. Okay, so 12 we cancel 12. So you have 17 over 7. Okay, so now your final answer will now be 2 whole number 3 over 7, because we have 2 7 in 17. So and you'll be left with what? 3. Okay, so now this is going to be the answer to the problem. So I want to believe we'll all understand this question here. All right, so I'm going to be stopping here for today. So because in the next class, I want us to continue with this question. All right, so we're going to be stopping today. So I want to believe we all understand this. So in the next class, which is going to be tomorrow, we are going to continue from there. So I want to employ you. You are just joining this platform and you have not subscribed to this channel. Kindly do that. And also, don't forget to always tap your like button whenever you are in the class. So I want to appreciate every one of you. All right. So we are going to meet tomorrow. Thank you very much. Bye bye. I love you all.